Here we go again. So we're going to talk about our second rule. We talked about the power rule earlier. Now we're going to talk about the product rule. And the product rule is going to be used when we're multiplying two things together in order to find the derivative. So our rule, if we're given h of x equals f of x times g of x, so we have two functions in the same variable of x, and we're being multiplied together, then h prime is going to be f of x times g prime of x, and to that we're going to add g of x times f prime of x. So we multiply the first to the derivative of the second, and then we add the second times the derivative of the first. I like to say 1d2 plus 2d1. So the first times the derivative of the second plus the second derivative of the first. It's just kind of the little mnemonic that I came up with, or I've used in the past, and that I like to think of when I do the product rule. I always say in my head 1d2 plus 2d1. Kind of gives you a little ring to the product rule. So can we find the derivative? So example 1, we have f of x. We have two quantities being multiplied together, and both of those quantities have x's in them, and we're multiplying those together. So we can find the derivative here, f prime of x. We're going to rewrite the first, so we have x squared plus 3. Then we're going to multiply that by the derivative of the second function. Derivative of x squared minus 5x plus 1 is 2x minus 5. To that we're going to add the second, or x squared minus 5x plus 1, and to that we're going to multiply the derivative of the first. Derivative of x squared plus 3 is 2x. So notice we're now using that power rule as we're doing the product rule. So we had a product rule, two things being multiplied together, but within that product rule we did a power rule. So you just can't forget about the power rule. Not going to work that way. Here, we could go ahead and clean this up if we wanted to. Again, if it's extended response, I would leave it. That's the first derivative. We're done. We could go ahead and multiply this out. If it's multiple choice, distribute it out, we get 2x to the third minus 5x squared plus 6x minus 15. And to that, we're going to add 2x to the third minus 10x squared plus 2x. Combining like terms, we'll end up with a 4x to the third minus a 15x squared, it looks like. Adding your x's, we get 8x minus a 15. And that go ahead and gives us a nice, clean, simplified version of that. So we can go ahead and find example 2 here. We got the first derivative of x sine of x. So again, we have a product rule. We have x times the sine of x. We're multiplying two things together that have variables. So our first derivative is going to be the first. So we have x, derivative of sine of x is cosine of x, and to that we're going to add the second, or sine of x times the derivative of the first, which in this case is going to be 1. Don't have to write the 1. I would suggest that you do just so you get into the habit of taking that derivative. Makes your life a little easier later on when we start taking derivatives of other more complicated things. But our final answer there is x cosine of x plus the sine of x. Example 3, again a little more. Product rule, we have 3x squared minus 2x times cosine of x. So our first derivative, we're going to rewrite the first function, or the first part of the function. To that, we're going to multiply by the derivative of the cosine of x. Derivative of cosine of x is negative sine of x. And to that, we're going to add the cosine of x. And then derivative of this first term, we get 6x minus 2. Again, we could clean this up a little bit. There's really not a whole lot you're going to do with it, so we're just going to go ahead and call it done. Example 4, f of x equals 2x tangent of x. Notice we don't have parentheses. We don't need parentheses necessarily to have a product rule. We got to be able to find our two terms though. So we have 2x, that's our first variable there, and then tangent of x is going to be the second part of that function. If you want, you could put parentheses around that, and it might denote what your first and second part of the function is. So our first derivative then, derivative, we have 2x times derivative tangent x is secant squared of x. To that we're going to add the tangent of x times derivative of 2x, which is 2. Again, pretty much just going to leave it like that. There's not a whole lot you can do. We could factor 2 out, I guess. So we'd have 2 times x secant squared of x plus the tangent of x. Again, if it's multiple choice, you just got to be able to manipulate your answer to be able to get to what they're looking for. Again, my rule of thumb is get to the answer that's posted or that's in the back of the book, so you know how to manipulate these things in order to get to an answer that we're going to be looking for on a multiple choice test or quiz, if it so happens to be. Let's see, example 5. We got find the derivative, then we're going to write the equation of the tangent line when x equals pi. And we're given the function f of x equals x plus 2 times the cosine of x. So in order to find the equation of the tangent line, remember we need the slope and we need a point. Well, we know the x value, we know pi. So we can find the slope or we can find the y value next. Doesn't matter to me. We can go ahead and find the y value, I guess. We have the function there. So we plug in pi, we have pi plus 2, and then times the cosine of pi. Again, you could leave it as that point if you want it. I don't see much of a reason to, because hopefully, remember, cosine of pi is -1. So we have pi plus 2 times -1, which gives us negative pi minus 2. So that's going to give us our, excuse me, our value, our y value of pi plus 2. Can we find the slope there? Of course, hopefully we can. Remember, slope of the tangent line comes from the first derivative, f prime of x. So our derivative, we have product rule. So 1 derivative cosine of x is just negative sine of x. 2, that we're going to add the cosine of x times derivative of x plus 2, which is very nicely 1. So we can go ahead now and plug in our pi. So we're finding f prime of pi. That gives us pi plus 2 times negative sine of pi plus the cosine of pi. We had cosine of pi up there, which is -1. Sine of pi, oh, isn't this nice? Sine of pi is 0, isn't it? So if we have the sine of pi, that's 0. So we have pi plus 2 times 0, which is just 0. So f prime of pi is 0 plus -1 or -1. So we have a slope of -1. 9 times out of 10, if it's an AP kind of question, we have a question like this, normally things are going to start zeroing out for us so that we get a nice, clean, simple answer. Not always, but generally it's going to work out that way for us. So we have our slope of -1. So I'm going to write my equation. My equation, y minus y1. y1 is pi plus 2, and that's going to equal my slope times x minus pi. Again, we could leave it like this. We could be asked to manipulate it into a simplified form. To simplify this, we could multiply the negative through, multiply that negative through. Just kind of a lot of different things that we could do with this in order to be able to get to an answer. But I'm going to go ahead and leave it like that because I can. All right, derivative. I write the equation of the tangent line again, and when x equals 2. Again, we need the slope, and we need the point. So we know the x value is 2. We need to know the y value. So we're trying to find f of 2 to start, I suppose. So we get 4 plus 10, not 9, minus 3 divided by 2. So we get 14, we get 11 halves, looks like, if I did my math correctly. Hopefully we did. If not, I'm sure you'll tell me about it. Our slope. So we really don't need the product rule with this. We could use the product rule, I suppose. Remember, this is all divided by 1/2 or being multiplied by 1/2. Or, sorry, dividing by 2 or multiplying by 1/2. So we could write this as 1/2 of x squared plus 5x minus 3. But notice we don't have a variable here with the 1/2. Since we don't have that variable, we don't have a product rule that we have to use. Oh, I didn't do that right. That's just f of x, not f prime. Now I'm going to go into my first derivative. So I can write this as 1/2 times 2x plus 5. I can go ahead and plug in my 2. So I get 1/2 of 2 times 2 gives me 4 plus 5 gives me 9, or 9 halves as my first derivative when x is 2. I guess f prime of 2 there. So that's 9 halves. So I can go and write my equation. Y minus 11 halves equals 9 halves times x minus 2. And that's going to give us that example. I have one last problem, kind of something that we might see on the AP exam. This kind of gets into our theoretical processes and being able to know exactly what's happening with this product rule. So if we give you h of x equals f of x times g of x, so notice that is the product rule, where two things being multiplied together is a product. We want to find h prime of 2. In order to find h prime of 2, we first have to find h prime of x. To find h prime of x, we got to find the derivative of this. So derivative of f of x times g of x, remember, is going to be 1d2, so f of x times g prime of x. And to that, we're going to add g of x times f prime of x. And then we're asked to find h prime of 2. That's going to give us f of 2 times g prime of 2 plus g of 2 times f prime of 2. Now we read the chart. F of 2. Well, this is telling us x equals 2, and we're looking at the f function. So when x equals 2, the f function is 4. So we get 4. G prime of 2, again, we're going to 2. G prime is going to be 4. So then we're going to add g of 2. G of 2 is negative 5. And we're going to multiply that by f prime of 2, which is 2. So that gives us 16 minus 10, or 6. Not a complicated problem, not difficult at all, as long as you understand what they're asking and the way they're asking it. Very typical of an AP kind of question, especially when doing a power rule or a product rule and eventually a quotient rule. Normally see something like this kind of theoretically on the exam. So good luck and enjoy.